Now the topic is air mass. Here the two words air and mass. So word air always related to the atmospheric phenomena, and normally the word mass is normally indicates the large volume and the large area or the huge body. So air mass is nothing but the huge body of the air, huge volume of the air. So what? Basically, the air mass is an atmospheric phenomena. The Tor Bergeron in 1928, he was the Swedish meteorologist. First time they formulated the ideas of what air masses. Okay. Now, air masses is an atmospheric phenomena. So, atmosphere range of atmosphere started from surface to the 10,000 kilometers. So, we have to identify the zone of the air masses. Normally, air mass observed within the troposphere. Okay. We are all familiar that on an average, the height of the troposphere is 0 to 18 kilometer, but there is slight variation in pole and in equator. And sometimes, a few special cases, sometimes air mass also found in the stratosphere too, rather lower level of the stratosphere too. Normally, the air mass is a phenomena of the troposphere, that is adjacent to the surface. The extent of the troposphere is on an average 80 kilometer. Now question is, what is air mass? What is air mass? Air mass is are the relatively large bodies of air. Okay, it's a huge body of the air. It's according to the three worth. Air mass is the three-dimensional body of air having the distinctive physical properties. Distinctive physical properties in reference to temperature, humidity, and the normal lapse rate. According to three worth, the air mass is a three-dimensional body of air having distinctive physical properties from the surroundings and relatively homogeneous in the terms of humidity, lapse rate, and density. So be clear. So air mass is a large body or huge body of the air, rather huge volume of the air. It can moves over the land and ocean surface. Okay. And third characteristic is very important. Air mass is horizontally uniform in character. Okay. Character in the sense of temperature character. Second one is the humidity character. And third one is the normal lapse rate character. Better to say, the suppose this is an air masses. Okay. This is an air masses. If someone moves or starts journey from that point, suppose this is in the upper layer of the troposphere, someone start journey from the point A to point B, but without change of the altitude and height, but through all its linear distance, the temperature, the humidity, and normal lapse rate. Better to say, temperature and humidity is the combination that indicates the density of the air is uniform throughout the horizontal direction. Horizontal direction. So, but within the vertical extent, there is variation in density, humidity, temperature, and normal lapse rate. This is the very important characteristic of weird masses. Horizontal character is uniform in the sense of temperature, humidity, and normal lapse rate. And in normal lapse rate. Okay, so we can take an example, or you can take an example of an air masses. And before going to the example, we can copy the definition of three word. The according to three word, the air masses is the three-dimensional body. It is a 3D body. Okay, three-dimensional body of air having distinctive physical properties. Distinctive physical properties means properties means in the sense of temperature, density, and the normal lapse rate, rather humidity. So having distinctive physical properties from the surroundings and relatively homogeneous. Okay, be clear. Air mass is homogeneous in character through its horizontal direction. Okay, relatively homogeneous in the terms of humidity, lapse rate, and density. So, air mass is an extensive body of air. It is a huge volume of air. It may be 1,000 square kilometer. It may be 1,000 kilometer long and maybe 5 to 8 kilometer in depth. So it is an immense or huge volume of air with uniform character in density, temperature, and humidity and lapse rate. Okay, through the horizontal direction, So next question is how its origin. Okay, normally origin place of the air mass is known as the zone of formation. Okay, origin place of air mass is known as zone as formation. For the formation of air masses, few criteria are very essential, few conditions are essential. So first and foremost criteria for the formation of air masses is the the homogeneous earth surface. This is very important thing. Homogeneous earth surface. First one is the homogeneous earth surface. It may be ocean surface, may be land surface, but may be homogeneous. Not the combination of land and ocean. Why not the combination of ocean and land? Because oceans and the continent, the specific heat of the ocean and continent is not the uniform, is not the same. uh, there is a difference between the surface temperature of the ocean water and the land surface. So regular topography and homogeneous earth surface. Okay, regular topography regular topography and the homogeneous earth surface is essential prerequisites for the formation of the air masses, but not the combination of ocean surface and land surface, because land and the water surfaces, that the ocean surface cannot have uniform temperature and uniform moisture content due to difference in specific heat. Second is point is that the high pressure belt, rather anticyclonic areas. Why the anticyclonic areas or high pressure belt? Uh, because high pressure belt, because comparatively high pressure belt is the main source of the air masses, means origin place of the air masses, because there is very intensive high pressure, but the variation of pressure with the surroundings areas is comparatively low. Okay, so pressure belt in Arctic areas, Siberia, Alaska, those are the very important source region of for the air masses, because high pressure belt is a zone of anticyclone. Suppose this is high pressure zone, and suppose this is the case of northern hemisphere. Suppose this is the northern hemisphere. So wind can enter. Sorry, wind can spread from the center. Wind can spread from the center. So this is a high pressure zone. This high pressure zone is a zone of anticyclonic condition, and that kind of anticyclonic condition, there should not be convergence of air. Here the air is diverging, going out, not converging. Okay, going out. So there should not be convergence of air. Air is moving out. So that type of condition is essential for the formation of air masses. And third one is the stable atmospheric condition. Though, so stable atmospheric condition for 5 to 7 days is essential for the formation of air masses. Turbulence atmospheric condition or the cyclonic condition not favorable for the formation of air masses. Calm and stable atmospheric condition is suitable for the formation of air masses. And last one is the time. 5 to 7 days. I mean, actually, it's related to near about 1 week. That period of time one air masses may attain the physical properties of the region. Air mass carries the characteristic of the temperature, humidity of the source region of the geographical area from which it's developed. So time period is very essential. Rather, four condition is very essential for the formation of air masses. First is homogeneous surfaces and regular topography, not the combination of land and ocean. Second one is the high pressure belt and the anticyclonic areas, because high pressure belt and the anticyclonic areas characteristic the high barometric pressure and low pressure gradient, and that is the favorable condition, and the convergent air are the favorable for the formation of air masses. Third one is the stable atmospheric condition, and last one is the at least 1 week atmospheric stability. And one important aspect of the air masses is that is air masses developed by the function of eddy exchange. We are not going details in the eddy exchange. Eddy exchange is the method that plays a major role in the formation of air masses. In that process, eddy exchange is nothing but the process of heat transfer from the low altitude to high altitude, and vice versa, low latitude to high latitude, and vice versa. And this process continues, the eddy exchange process continues until the temperature and the humidity character of the both region comes in equilibrium. So just try to remember that eddy exchange is the essential method for the formation of air masses. Now come to the principal source region of air masses. Okay, there are 6 major air masses zone or the source region of air masses. Those are the polar zone. Polar zone may be oceanic and may be continent. So first one is the polar oceanic zone. Okay, maybe in the northern part of Alaska and the northern ocean. And second one is the polar Arctic continental areas. Third one is the tropical oceanic area, and fourth one is the tropical continental area. Fifth one is the equatorial region. Here I would like to mention, suppose this is 0 degree, this is the trade wind belt in northern hemisphere, and this is the trade wind belt of southern hemisphere. So this is the doldrum zone, this is the D for doldrum zone, and here the two trade wind, those are the easterlies, those are the easterlies trade wind meets at that point. And this doldrum zone is a good zone, good major source zone of air masses. And last one is the monsoonal land. Monsoonal land, also monsoonal land, particularly various part of Asia, even in the part of India, is the very important source region for the air masses. So air masses, after developed of air masses, after developing of air masses try to move from the source region. Okay, and suppose air masses, suppose this is Siberia, suppose this is Siberia, air masses origin and that places. Siberia is a very cold and continental climate, and the air masses origin after staying 5 to 7 days within the in the Siberian zone, and getting the characteristic uh, of the weather phenomena of the Siberia region. And after getting the characteristic of Siberia region, the air masses moves or run away from the source region. When the air masses mature and developed completely and start journey and moves away from the source region, then the air masses modified, that is known as modification of air masses. Okay, now come to the, so one important thing is that air masses moves from the source region. When air masses start journey and moves from the source region, there isn't changes in its character, inherent character. There isn't changes in inherent character which achieved by the air masses from the source region. When air masses start journey, suppose this is source region, start journey from the source region and move, suppose low latitude or high low latitude, and even in the high latitude from the source region, there is changes in the temperature and humidity character and lapse rate of the air masses. That changes normally known as the modification of air masses. So modification of air masses depends on the four character. First one is the inherent or initial characteristic of air masses, which air masses achieved from the source region. That is the inherent character of air masses, its change. And second one is the nature of the surface over which a particular air masses moves. The nature of the surface over which a particular air masses moves. Okay. And third one is the path followed by the air masses from the source region to the affected area. Okay, and fourth one is the time taken by the air masses to reach a particular destination. On the basis of these four indicators, air masses is ever changing when the air masses start journey, and each and every step of the journey, air masses changes its character by the underlying surface, by the nature of the path and the time taken to cover the path. That is known as modification of air masses. Is maybe two types: mechanical modification, we are all familiar with the mechanical modification, and next one is the thermodynamic modification. Okay, thermodynamic modification is very important for the classification of air masses. Now we can classify the air masses. Suppose now we can classify the air masses. Okay, air masses. Suppose air mass may developed from the continent or ocean, and it's also developed from the pole or in the tropical region. So P for pole and C for continent. Okay, we can take another paper, we can write down C for capital C for continent, P for P for pole. Before going in details, okay, so air masses can be origin from the pole and may origin from the tropical region. P for pole and P for pole here and T for tropical region. We are using the English capital letter. Okay, T for, and polar region may be continent like Siberia, Alaska, maybe northern sea. Okay, so P region may be divided into the two parts. Pole may be continent and may be marine. C for continent and M for marine. Okay, we can use the small letters. Okay, and we can use the small letter before the P. So we can put P and P. So air masses basically are two types. It's may developed in the pole on the basis of geographical area. On the basis of geographical location or area, we can divide the pole and tropical area. Okay, tropical area may develop in continent and over the ocean. C for continent, M for maritime or ocean. Similarly, the tropical zone may be on continent and may be in ocean. So T for T, before T we can put C and A. So this is the continental polar air masses is developed over the continent near the pole, and maritime polar air masses that developed near the pole but in the ocean surface. CT, continental tropical air masses, they are continental and tropical. It developed in the tropical region but over the continent. It developed in tropical region but over the ocean surface. Now up to that point we can classify on the basis of geographical area. Now come to the point of modification. when the air masses, I have told earlier, that moves from the source region, the character, inherent character that achieved by the air masses from the source region has changed, and there is a gradual change. So now we classify the air masses on the basis of, or rather we pursue the end part of the classification on the basis of modification. So continental polar, that is C and P, that is C and P, that air masses may change. It maybe get warms or maybe cool down. So if it cool down, K for cold and W for warm. Okay, if it get warm, then continental polar air masses, this is, and we can put W within another color with the help of another color. Suppose we can take a blue, okay, and we can take W. Okay, so continental polar masses may get warm from its below. Then I will discuss the how it will get warm from below. I will discuss later. And continental polar air masses. Suppose continental polar air masses. Suppose a air mass is developed from the Siberia, and it's a latitudinal, suppose 80-degree north latitude is developed in 80-degree north latitudes and moves towards 60 degree to 50 degrees north. So it is coming from the high latitude to low latitude. So there is an adiabatic heating process. Due to heating process, the continental polar air masses, that was very cold air masses, that gets cools and that gets warm by the influence of the underlying temperature and underlying humidity characteristic. And this cold air masses, that is continental polar air masses, gets warm from the below, that is known as CP air masses. And if the CP air masses become cold, suppose it developed in 80-degree north latitudes and moves towards more north, that is due to 90 degree, moves towards 90 degrees north, then it's become more cold, so heated from the below, that is CPK. So MP will be same. Suppose MP, M, and suppose P for P. So maritime polar air masses may be heated from below and may be cooled from below. And similarly, CT air masses, suppose CT air masses and MT air masses. Okay, those are the CT and CT, MT and MT air masses that may be heated from the below and may be cooled from the below, may be heated from the below, may be cooled from the below. So we can get 8 types of air masses on the basis of its nature of modification. After getting warm or cold, it may be stable or unstable. Okay, both become maybe stable and unstable. Okay, so we can divide it like a, suppose we can take this paper little bit in that direction. So okay, CPW air masses, CPW air masses may be stable and CPW air masses may be unstable. CPK, continental polar cooled from below air masses, may be stable or CPK become unstable. MPW may be stable, MPW may be unstable. MPK may be stable, MPK may be unstable. CTW may be stable, CTW may be unstable. CTK may be stable, CTW may be unstable. Okay, and maritime tropical war air masses may be stable, maritime tropical war air masses may be unstable. Maritime tropical cooled from below may be stable, maritime tropical cooled from below may be unstable. So we can divide the air masses in 16 June, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16 June. So we can take an example how it's modified. Suppose this is pole. Okay, suppose we can take an example. These air masses are developed over the continent. Suppose in Siberia, eastward journey from 80 degree north latitude move towards the 60 degree or 40 degree north latitude. Suppose this is 80 degree and moving north, that is 60 degree. So it is coming from the pole towards the equator. So it gets warm. So it becomes CPW. Continental polar air masses become warm air masses. Then it's come to the 30 degree north latitude and become unstable. Unstable air masses is very relevant for the climatic condition and EL precipitation that become the CPW as a unstable air masses. Okay, similar phenomena. Oh, there is no watertight boundary. All the air masses moving and changing their characteristic and form the various types of air masses. So these are the types of air masses and it is ever changing. Now we can take an example with the visualization. This is the world distribution of air masses. Suppose this is CP, this is Siberia, this is Siberia zone. This is the continental polar air masses. Suppose these air masses comes to that direction. This is 90 degree. Suppose this is North Pole. If some air masses or ocean current comes from the pole towards the equator, then it gets warm. Similarly, CP air masses when come to the tropical become CT air masses. It become continental tropical air masses. If CT air masses moves towards south towards the equator, suppose it comes over the ocean and it become maritime air masses. After become maritime becomes it become unstable. It hitted from the below, it uh, become tropical maritime warm air masses and become unstable and EL precipitation. So modification process, on the basis of modification process and the geographical region, we can divide the air masses on the 16 basic type. It may be polar or maybe tropical, maybe continental and maybe maritime. And on the basis of thermodynamic modification, it may get warm from the below or gets cools from the below. On the basis of that, air mass becomes stable or unstable. We can identify the 16 types of air masses. Now, next one is what is the significance of air masses? What is the significance of the air masses? Okay. Uh, Significance of the air masses is very important and relevant for the formation of frontal zone, latitudinal heat balance. We are very familiar with the cyclone and supercyclone condition and the temperate cyclone. All are related to the formation of front, and front formation is directly related to the air masses. So suppose this is a warm air masses, this is a cold air masses. If two air masses moves and meet in a margin, that margin is known as front. Suppose this is continental, this is United States of America, this is the marine air masses, this is the continental polar air masses, continental polar, but this is maritime tropical, this is maritime tropical. So this is warm air masses, this is cold air masses. So this zone, there will be a frontal zone. A frontal zone is a zone of, you are all are familiar that there are four types of front: cold front, warm front, occluded front, and stationary front. And mid-latitude cyclone, rather extratropical cyclone, is always related to the formation of front. So front formation, okay. What is front? Now question is what is front? Front is the contrasting air masses. Front is the boundary of two contrasting air masses, is known as front. The boundary of two different type of air masses is called front. So front formation is related to the air masses formation. And next important thing of related to the air masses is that it helps to latitudinal heat balance. Okay, latitudinal heat balance is related to the front. Okay, latitude. What do you mean? How we will manage the latitudinal heat balance? We are all familiar that when we are all familiar in the cases of ocean water too. Suppose this is pole, this is equator, and this is 90 degrees south, and it is 90-degree north. Suppose if air masses moves from the pole to equator, it's great get warm, and if air masses move equator to pole, it gets cool. Okay, the basic latitudinal heat balance. Basically, we can take an example that westerlies that related to mid latitude. Suppose this is the earth, this is 23.5 north, and this is the westerlies zone. Westerlies zone is related to the two important air masses, that is the polar air masses and the tropical air masses. In mid latitude zone is a zone of temperate cyclone. In temperate cyclone zone, we can if you try to remember the situation of mid cyclonic, mid oceanic, mid latitude cyclone, but temperate cyclone. Suppose polar air is easterliest, come as a easterliest wind, and westerliest that comes from the tropical region meet in a boundary, and both polar air, this is polar easterlies, and tropical air masses as a westerlies runs parallel, and tropical air masses is comparatively warm air masses, this is comparatively warm, moves towards that direction, and the cold air masses move towards that direction and create a front. And we are all familiar with the sixth stage of temperate cyclone. Temperate cyclone is directly related to the air masses. Okay, and another thing is that the latitudinal heat balance, though, so heat comes from pole to cold air masses come from pole to equator, and warm air masses move from equator to pole. It maintained the latitudinal heat balance, and the planetary wind belt helps to manage the terrestrial heat balance in planet through the planetary wind belt. Now come to the point for the visual interpretation takes the help of this diagram. Suppose this is a warm air masses, okay, and this is the cold air masses, okay, meets in a boundary. This is the front zone, this is the front zone. Suppose, so two contrasting air masses creates a boundary, and this is known as a front zone. On that front zone, warm air masses moves half, okay, and form cumulonimbus clouds, and in last stage it formed the cirrus cloud, and yield precipitation become unstable. So for the precipitation, mid latitude cyclone, latitudinal heat budget, and the trade and the pressure belt and related heat balance, Airbus is very much relevant.